Okay, 2.4. We're going to finish 2.4, and then we're going to start, we're going to do 2.5. Okay, so example of 5. Here's what it says. Write an equation of the line that passes through, write an equation of the line that passes through 5, -2, and 2, 10. Okay? So now there was one on your worksheet like this, and I kind of told you what you should do. But I'm going to go ahead and work one just to make sure. I'm going to tell you the biggest problem that I saw on the test that I was amazed at, okay? This is what kids were doing, okay? Like for this problem, this is what they would have done. They would have plotted this point on some graph. Either they drew it themselves or they went and got one of mine. And this point, and then they drew the line and tried to estimate what the y-intercept was, and then tried to write the equation. Okay? Y'all, did you ever see me plot 2 points and guess about the slope or anything? No. So I had kids graphing points and saying, and drawing lines between them and then saying, yeah, I think these two lines are perpendicular or parallel or whatever. People, we don't go by looks, okay? We don't go by if they appear to be perpendicular or parallel. We're going with numbers. We're sticking with facts, okay? So you should have been finding the slope. Here was another one that they did. Tell me which line is steeper. And they would graph the two lines and go by looks. People, how do you know if a line is steeper than another line? Its slope is what? Yeah, it's bigger, okay? Its slope is bigger. Okay, so these were some of the responses that I had. They said the rise in line whatever is bigger than the rise in line 2, okay? Can I say that? Is this rise bigger than this rise?
Yeah.
Is this rise bigger than this rise?
Yes.
Is this line steeper than that line? No. People, you can't say that. The only way that you can compare fractions is if they have a what? Common denominator. Okay? I'm not wasting my time finding a common denominator. I'm just going to see which number's bigger, even if I pop it in my calculator. I'm just going to see which number's bigger, and the bigger number has the what? What kind of slope? Steeper slope. The bigger number has a steeper slope. That's it, people. It is that easy. Okay? Do not be graphing stuff. That's crazy. All right. So what do I need? I'm trying to write the equation of a line. What do I need to write the equation of a line? The slope and a point, right? Well, I got 2 points. Okay? So obviously I can find the slope. I'm going to show you something. This is called the point-point formula. When would you use the point-point formula?
I thought it was point slope formula.
Okay, it is. That's when you're given a point and a slope.
Oh.
Okay? Guess when you can use the point-point formula? Yeah, when you have 2 points. Y'all, guess when I'm going to use the point-point formula? Never, never, ever. Okay? So I'm going to show you what it looks like. Y minus y sub 1 is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1 times the quantity x minus x sub 1.
That's so extra.
That is very extra, right? Very extra. What's the only thing they did, people?
Add slope.
Yeah, they put the slope formula in for m. Oh my gosh, by the time you plugged in all your numbers in this mess, you'll get lost. It's crazy. Don't do that. What should I do? I should just find the what? Slope between these 2 points. Now, did I tell you something to do to make it easier for you to find the slope and not make careless mistakes.
Put them, stack them.
Okay, stack them, and do what?
Circle the line.
Okay, so a bunch of people on the test said, nah, I don't need to stack them, okay? Some of them were the same kids that said, nah, I'm not gonna join Remind, okay? Some of them were the same kids that said, nah, I'm not gonna learn how to upload my work as one PDF.
I just forgot about that.
And then I'm going to text Miss Davis and say, Miss Davis, I don't know how to upload it as one PDF. Because Miss Davis is gonna say, not my problem. Not my problem, figure it out. Figure it out, dear, okay? I'm not going to tell you how to do it. And then some of you put the X on top instead of the Y. That's why I circled the Y, so I'd remember. Okay, another way I remember is I always write this, delta Y over delta X. Okay? Now, what do you want to say on the Y's? Who do you want to be first?
10.
10? So that would be 10 minus a negative becomes a positive, right?
So
Now, if you say 10 minus a negative 2 on the top, what do you have to say on the bottom?
2.
Yeah, what order you can do whatever order you want, but you have to keep it. You can't change the order. That's what I saw 2 kids did that. They started one way and then they went back and did the other way. They would say 10 minus a negative 2 and then they said 5 minus 2. And it makes your slope wrong, okay? So it should be 2 minus 5. It's gonna give you the wrong sign, is what it's gonna do. What's 10 plus 2?
12.
Over 2 minus 5. And 12 over negative 3 is negative 4, okay? So that's my slope. My slope is negative 4. Now, which point am I supposed to pick? Yeah, it doesn't matter. So which one are you going to pick? Why? Yeah, we're gonna stay away from those negative numbers. I'm staying away from fractions. I'm staying away from big numbers. I'm going to, if there's a 0 in one of them, I'm probably gonna pick him, okay? So we're gonna pick this guy right here, 2, 10. I'm gonna use the point slope formula. Remember the example I set, guys? I always write the formula down. Y minus y sub 1 m times x minus x sub 1. If nothing else, it makes your brain go, wow, you are so smart. And then we just plug our stuff in. This is x sub 1, y sub 1. If we think we're smart, are we smarter? Oh, yes, you are.
No confidence.
Yeah, that's exactly right. Math is a lot about confidence. You know, it's a skill, y'all. It's just like if you played ball and every time baseball or softball and every time you got up to the plate, you said, oh Lord, I hope I hit this ball. Are you gonna ever hit the ball?
No.
You're not going to, people. You gotta step up to the plate and say, let's see, where would I like to put this ball? Okay? So, and pick a place and then go for it. All right, y minus, what's y sub 1? 10 is equal to, what's m?
Negative 4.
Times x minus 2. All right, distribute and collect, distribute and collect. So distribute, be careful when you distribute, guys. These are all the skills that we talked about at the very first of school. Distributing a negative, that's where my kids are gonna mess up. So y minus 10 is equal to what?
Negative 4.
X plus, very good. Now I'm gonna collect my like terms, so tell me what to do. Add 10 to both sides, very good. So y is equal to negative 4x plus 18. Now guess what I'm gonna do now? People, oh my word, why would you not check it? It takes 15 seconds to check this thing. Go to y equals negative 4x plus 18. It was already in here, but I pretended like I put it in there. Okay? And then where am I gonna go? Table. Second and table. I'm looking for, there's only one line that goes through those 2 points. 5,
It was 0, 18.
negative 2, and 2, 10. Boom. It's right. I know I got it right. Anybody got a question?
Nope.
Everybody okay? Thanks.
One thing I noticed, so the points formula is the exact same as the point slope formula. It just plugs in the slope.
That's exactly. All they did on this formula right here is they plug the slope formula in for that m right there, But here's what happens, kids get tangled up in here, all right? So just go ahead and find the slope and then use the point slope formula. It's just a better way to do it. This is a formula and, you know, you could use it, but I'm not using it, people. And I'm gonna say if I'm not gonna use it, you probably shouldn't. All right, so here's example 6. This is the last problem in 2.4. Okay, it's a word problem because there are word problems at the end. We're gonna talk about those too. So in the school year, ending in 1993, 2 million females participated in high school sports. By 2003, the number increased to 2.86 million. Write a linear equation that models female sports participation. Okay. Have we been writing linear equations? Okay. So we should be able to write a linear equation. Do you agree? All right. What do we need to write an equation? Yeah, you need a slope, right? Does everybody agree with that? We need a slope and we need a point. You with me? Okay. So in order to find the slope, I need 2 points, right? They didn't give me the slope, so I'm gonna use, so they must have given me 2 points. Do you agree? All right, what's the first point?
1993 and 2 million.
Very good. And remember how we always talked about the X, if you have a time, that's an X value. Okay, if you have a time, that's an X value. It could be a year, that's represented by a time, or it could be like 2 hours or 10 minutes or something like that. All right, but that's my X value. So this is 1993 and 2 million. Can I just write 2 or do I have to write 2 with 6 zeros on it? I can just write a 2, but what do I need to make sure I understand? Yeah, it's in millions, okay? It's in millions. It's not just 2, it's 2 million. Is there a difference between 2 and 2 million?
Yes.
Yeah, $2 and you know, what, I don't even know if you could buy a drink anymore for $2. Okay, but $2 million, we'll buy everybody a Sonic drink, right? What's my next point?
2003.
2.86, okay? So we need a slope, right? I'm gonna circle those Y's. I'm gonna find it. M is equal to delta Y over delta X. All right? I'm going to say 2.86 minus 2. 2.86 minus 2. That's what I said on the top. What do I have to say on the bottom?
2003 minus 1993.
Very good. 2003 minus 1993. All right? So on the top you get 0.86, okay? And on the bottom you get 10. Is this acceptable? People, this is illegal. You cannot have a decimal within a fraction. That's against the law, okay? Some of y'all left a decimal within a fraction on your worksheet, and I counted it wrong, okay? You never do that. This is a real life problem. Can I use decimals? Yeah, y'all, real life's not pretty, okay? It's not perfect. It's not gonna be nice, pretty numbers. It's gonna be messy. So use decimals in real life problems, there's nothing wrong with that. So 0.86 divided by 10 is 0.086. That's my slope. Okay? What point you gonna use?
1993.
Yeah, I'd use 1993 and 2. Now, y'all look, I want you to understand, if I had on this problem right here used 5 and -2 for my point, x of 1 and y sub 1, would I have ended up with the same answer as this?
Yeah.
Yes, you would. You would, okay? You would have, it would have been the exact same numbers and everything, okay? So let's do this one. We're gonna say y minus y sub 1 equals m times x minus x sub 1. I'm gonna plug my stuff in. This is my x sub 1 and y sub 1. So I'll go y minus, what's y sub 1? 2 is equal to, what's m? 0.086 times x minus, what's x sub 1? 1993. All right, what do I always say? Distribute and collect. Distribute and collect. So we're going to distribute here, okay? I'm gonna get y minus 2 is equal to 0.086x minus, and this is where I think, woo, I'm so glad I got a calculator. I'm gonna go 0.086 times 1993, and you're gonna get 171.398. Now what do I do? Collect. So I'm going to do what? Add 2. So plus 2 and plus 2. Now watch this. Everybody look up there at the board for a second. Y is equal to 0.086x. Guess what the careless mistake right here is going to be? To write down what?
To add 2 with
That's
8.
exactly right. They're going to go 173. I don't need a calculator. 173 plus 3, no, people, these are unlike signs. Okay? You have to subtract them. You have to be paying attention. Okay? So when you subtract them, you get 196, a negative 169. Sorry. I was like, wait, that didn't make sense. Do you see what I'm saying about talking to yourself out loud? I said 196 and my brain went, whoa, wait, where'd you get that? 169.398. Okay, so this is my equation. All right? Here's my question. How many girls, I'm going to tell you first of all, before I do this, I'm going to tell you, do you know why that number grew so fast? In 10 years, 86,000 more girls were participating in sports than they were 10 years before that. Do you know why?
They added more.
No, because back around this time right here, they did a study, and here's what the study said. The study said that girls who participate in sports are less likely to drink, use drugs, or get pregnant. So what did all their parents do? You are playing sports, I don't care if you like it or not, okay? They're just trying to keep their kids in line, right? Doing the best that we can do. So that's why it grew so big. A bunch of people made their kids participate, and then a lot of them liked it. So how many girls participated in, let's go 2017, okay? How many girls participated in 2017? I'm gonna let you do that one, okay? What did y'all do? Okay, plug in 2017 for X. calculator, right? Is that what y'all got? Yeah? Good answer? There you go, okay? So, no, y'all aren't talking to me anymore. Y'all are like shaking your heads. I can't hear your rocks rattling all the way back here. So this is not a good answer. Why? Million. Million. Is there a difference?
Yeah.
Yes. First of all, I don't know, who wants to see 64 thousandths of a girl out there playing softball? Like, what is that, like an arm or something? No, that's gross. So, it's 4.064 million girls. All right? Everybody okay? All right, I want to talk about this. Variance. Variance. Is this important? Anybody know where it comes from? The worksheet. Yeah, it comes from the worksheet. Okay, it comes from the worksheet. So a lot of kids don't know what variance means. All right, so I'm going to give you two examples of what variance means. Look, my equation says that in 2017, 4.064 million girls participated in high school sports. Do you think that's the exact number? No. It might be close, right? But it's off a little, it varies just a little bit, okay? So a variance is how far you're off, or how far you're allowed to be off, before I can still call it good. Let's pretend that we have a company and we make baseballs, okay? Does anybody happen to know what the diameter of a baseball is? I didn't know either, and nobody knew last period, so I made up a number, and they said they thought it was close. But anyway, I'm gonna say 4 inches, all right? I don't think it's quite that big, but it's around. We're just gonna say, I'm just gonna use 4, okay? So we make baseballs, and baseballs are supposed to be 4 inches in diameter, okay? Do you think that every baseball we make is exactly 4 inches in diameter? No, in a perfect world, it would be, but obviously that's not where we live, okay? So they're not going to be. Does that mean that we chunk every one that's not exactly 4 inches? No, because you're allowed a variance. Let's say that the baseball people said that we could vary 1/8 of an inch, okay? So that means that we're gonna accept any baseball that is between 4 1/8 inches and 3 7/8 inches. Do you see what I'm saying? That's my variance, okay? That's my variance. So here is the problem that you guys are going to do, all right? So, U.S. population from 1950 to 1960. The rate at which the U.S. population increased was approximately linear. Did it say it was linear? No, it said it was kind of linear, almost linear, approximately linear. In 1950, the population was 152,271,417. What's that?
That's a number.
What is that?
That's a point.
That's a point, people. That's my X and my Y. That is a point, okay? In 1960, the U.S. population was blah. That's a point, people. Look what they're going to say. Assume that a 5% variance of the actual from the forecast. The actual is what it was. The forecast is what I predict it to be, is acceptable. So I can be off 5% and I'm still okay. But if I'm more than 5%, is it a good prediction? No, it's not. That's what they're saying. I can vary 5%, but if I'm outside that 5% variance, then it's not acceptable. Okay? Number 13 says, write a linear model for the U.S. population from 50 to 60. People, is that just what we did? Okay? Look at this right here. All right? So let t equals 0 represent 1950. That's going to change things, because then instead of this point being 1950, 152 million, it's going to be what? 0, 152 million. Okay? And if 1950 is 0, what's 1960? 10. You see what they did? They just changed it up a little bit, but that's okay. You can still do it. All right? You can still do it. All right, so here they want you to write the equation, and then here's what they're going to do. In 1970, they're telling you what the actual population was. Is the model that you wrote up here, is it going to be pretty?
No.
People, this ain't going to be pretty. Look at those numbers, okay? This is not going to be pretty. I suggest you using decimals and stuff, all right? So don't be rounding stuff off. Is the model from 50 to 60 inappropriate for the 1970s? That means that he can't be outside that 5% variance. Do you agree? So I'm going to use this to predict what the population is. 1970, what's X going to be? 20. You see what we're doing? Okay, so you're going to plug a 20 in. Why are you plugging a 20 in? Because 0 represents 1950. 10 represents 1960. 1970 is my 20. Okay, now, something else that you need to know. How do I find a percent? All right, now there's different ways of doing this, but this is the way I like, okay? But some of the kids did it a different way, and I'm okay with that. So I have to be within 5%, so I need you to know how to find a percent, okay? My percent is the part over the whole. Do you agree?
Yes.
Okay, that's what you learned in 6th grade, part over the whole. The part is how far you're off. Okay? It's actually the difference in the actual and the predicted. You're going to subtract those and see how far off you are. And then you're going to divide by the actual. Do you understand that? Yes or no?
Mm-hmm.
Okay? So you're gonna plug your number in and get what you predict the population to be. Okay? It's obviously probably not going to be exact, okay? That would be like a miracle, and it's not, okay? So then you're going to see how far off am I? So you're going to subtract those two numbers. And then you're going to divide by this actual number. And that will tell you, it'll give you a decimal. If you want to turn it into a percent, you can move your decimal point 2 places to the right. Okay? If you're within 5%, you're like, yep, I'm good. I was only 3%, or I was only 2%, or whatever. Okay? Anybody got a question? All right. So here's the next thing. We're going to start 2.5 now. is direct variation. Okay? Direct variation. Now, we have kind of been talking about direct variation. We've kind of been talking about all this stuff, but direct variation is a very specialized equation, okay? So it just kind of like, you know how we talked about functions, and then we said a specialized function was a one-to-one function. It was a function, but it had something special about it, okay? So we've been talking about linear equations, so this is going to be a linear equation, but it has something special about it. All right, so here's what you need to know. This is the one thing you need to know, okay? Y is equal to kx is what represents a direct variation. Everything that I teach you today will come from this right here. Everything that you learn about a direct variation will come from this right here. You looking at this and making statements or assumptions about it. Okay, so this k right here, k is my constant of variation. K is my constant of variation. Now I'm going to tell you this. If you got a book and you're looking at the book, they call it A. I don't know why, but for years they called it K. I always laughed and said, oh, you knew that was a math person, because someone said, what are we going to call the constant of variation? And someone said, oh, let's call it K, because constant starts with K. But now they've changed, and sometimes they call it A. Most of the time it's called K, but whatever. It's just a variable. All right? So there's my constant of variation. What have you been calling this number right here? Yeah. People, this is so slope. That's the number in front of and multiplied by x. It is the coefficient of x. He is my slope, okay? He is my slope. So, this is just like y equals mx plus b, except I got a k right here, all right? Now, let's write this down. This is extremely important. What does that mean?
That's what it is.
It is. It is. In order for it to be a direct variation, the graph must go through, look at this equation over here. What's his y-intercept?
0.
Zero.
We must go
through zero.
That's exactly right. He doesn't have a y-intercept, so it has to be 0. So he must go through the what? The origin. 0, 0. It must go through the origin. If it doesn't go through the origin, it is not a direct variation. Okay? If it doesn't go through the origin, it is not a direct variation. So, let's see if you know what I'm talking about. Is the graph a direct variation? Okay? Is the graph a direct variation? So I'm going to draw a graph. I'm going to put some lines on it, and I'm going to ask you, are they a direct variation? Is this going to be hard?
No.
No. People, this is just like on the test. I'm telling you right now, there's going to be problems like this on the test, and some of you are going to miss it. I don't know where you are right now, but you should join the class, okay? Because we're fixing to talk about something important. All right.
No.
Is that a direct variation?
Nope.
No? Why?
Because it doesn't go through the origin.
And doesn't go through the origin. Okay? Doesn't go through the origin. What about this guy right here?
No.
No. No. Why?
It must be.
Doesn't go, is he close?
Yeah.
Closeness doesn't count in direct variation. Okay? No. Doesn't go through the origin. Okay? What about this guy right here?
Yes.
Mhm.
Yes. Why?
Origin.
He goes through the origin. Okay? He goes through the origin. Now, people, was that hard? That's not hard. You know what I call that? People, that's just a present from me. Okay? Like what? I'm trying to give you points on your test. Is it a direct variation? I don't know. Does it go through the origin? Okay? That's an easy one. All right, what if I did something like this? What if I said, is the equation a direct variation? What if I ask that? Is this equation a direct variation? So here's the first one. Are you ready? All right, don't blurt the answer out. Give everybody a chance to look at it. Okay? Y equals 3x minus 5. Is that a direct variation?
No,
Why?
because it doesn't have zero as a.
Yeah, my y-intercept is not 0.
Could you put the B and then the not equal sign, and 0?
Yeah, but I want you to be, okay, so here's something that you guys need to learn. All right, B is not 0, but do I know that you know what B is?
No.
Do you see what I'm saying? So when I ask about this, I want you to be as specific as you can be. All right? My y-intercept is not 0. You could have said my y-intercept is not 0, it's -5. Okay? Here's what I don't want to hear. my y-intercept is -5? No, because my y-intercept is -5. So what does that mean? It could be +3 and I'd be okay? Do you see what I'm saying? That doesn't tell me that you know. That just says you know what the y-intercept is, but do you know what it's supposed to be? All right, ready? Here's the next one. 2x minus y equals 7. Don't yell it out. 2x minus y equals 7. Yes or no?
No.
Very good. No, it's not. What about this guy right here? Don't blurt it. Y equals 1.78x. Yes or no?
No. Yes.
Yes. Okay? If it is a direct variation, what is his constant of variation? 1.78. Anybody got a question? Okay, let's do one more. 3y plus 2x equals 0. Is that a direct variation? Okay. What's his constant of variation?
Negative 2.
Oh, 2/3, -2/3.
There you go. Y'all, you have to solve for y. Okay, you have to solve for y. So right here, what you have to do is you have to say 3y is equal to -2x. Remember, it's the same thing as slope, guys. And divide by 3, and there it is right there, -2/3. Anybody got a question? Nope, no question? All right. Let's try another problem. This is example 1, okay? Example 1. Write and graph a direct variation equation that has -4/8 as a solution. Okay? Write and graph a direct variation equation that has -4/8 as a solution. All right, so still trying to get you to understand how many answers sometimes you have in a problem. How many answers does this thing have? Say it. 2. Very good. One is to write the equation, and one is to graph the equation. Did it say graph it first?
No, it says
No.
right.
Yeah, it says write the equation first. Let me ask you this, okay? Because some people are like, well, crazy Miss Davis, you can't graph a line if you're only given 1 point. If I'm given this 1 point, could I graph the direct variation line? Because what? It goes through the origin, okay? That's not what they asked me to do, guys, all right? So I don't want you to do that. So, what is the only thing that I told you you had to know?
The cons, okay.
It's the same here at K or so.
Mm-mm.
Has to go to the original.
What was the equation I told you? It's the only thing you had to know. Y equals kx. This is what you gotta know, people. You gotta know this. From this stems everything else that we've learned today. Okay? Y equals kx. Well, what did they give us?
-4/8.
What is that?
Up to 1.
An x and a y. Let's plug it in and see what k is. Okay? What is y? 8 is equal to k times what's x?
-4.
-4. Now what am I gonna do?
Divide by, or, yeah.
Yeah, I'm gonna solve it by doing what? Yes, divide by -4, you were right. These go away, and k is equal to, what's 8 divided by -4? -2. Okay, so k is equal to -2. Is that the equation that they're looking for?
No.
Y'all, that is not it. That's gonna be a mistake that somebody made. Okay, they're gonna solve for k, and then in this blank, they're gonna write k equals -2. Y'all, that is not a direct variation equation. That is the constant of variation, and that's all it is, okay? So my equation would be what?
Y equals 2x.
Negative 2x. Y equals negative 2x. And what is my slope? And what is my y-intercept? Okay, so, let's talk about this for a second, because on the test, a bunch of you missed the graphing problems, okay? So that's why next week when I'm gone that day, you're gonna practice some graphing problems, all right? And you're gonna practice on your chapter review and your chapter test. Even though I haven't taught you, no, I have taught y'all everything. The other classes, I won't have taught everything, but y'all I will. Y'all's test will be Friday, okay? So that'll give you a chance in class to work on a little graphing paper and to do the chapter test and chapter review. And I'll leave my book over there, all right, with it open. Some of y'all found out, you're like, hey, Miss Davis, can you send me a picture of some problems? Like, nope, I don't have my key here, okay? So y'all take pictures of those. All right, so this, when you're graphing, am I looking for specific points? Yes. Yes, I am. Could I just put this in my calculator and go to my T-chart and write 2 points down and graph those 2 points and draw my line?
Yep.
Well, I don't know if you're lucky enough to get the ones I'm looking for, okay? What's the first point I'm looking for?
0, 9.
That right there, that y-intercept. If that y-intercept is not one of yours, you're off to a very bad start. The other points should come from this slope right here, okay? So I'm gonna go down 2 and to the right 1, down 2 and to the right 1. These are actually the 3 points I'm looking for. Some kids will go up and to the left, and I was like, okay, you can do that. Dangerous, but you can do it. A negative slope, which way's my line going? Down. All right, anybody got a question? Okay, here's my next problem. This is example 1B. He says, X and Y vary directly. What does that mean?
Put together. They correspond with each other.
Yeah, but what do I have?
Direct variation.
You have a direct variation. Okay, you got a direct variation. And X equals 2/3 when Y equals -10. What's that? A point. What? Same thing we got right here, people. It's exactly what you gave me right there. All right? Write a direct variation equation that has this point. Boom, we could do it. Here's what they say. Write an equation, oh, I got this, that relates X and Y. Now people, if it's gonna relate X and Y, what's it gonna have in it? If it's gonna relate X and Y, what's it gonna have in it? If I'm gonna write a paragraph that relates, I don't know, my class to somebody else's class, then what do I have to talk about in there? My class and their class, right? If I'm gonna write an equation that relates an X and a Y, what has to be in your equation? X and a Y. If there's not an X and a Y in your equation, people, it doesn't relate X and Y. Okay? So that relates X and Y, then find Y when X equals 12. Okay? How many answers? 2. Gonna write an equation and then find Y. Write an equation and then find Y. This one right here, that's where people are gonna mess up. They're gonna get this right, but they're not gonna get this right. All right? So let's see if we can do it. What's the only thing I said you had to know? Y equals KX. You better know it, people. Y equals KX, just like Y equals MX. Okay, so here we go. Here's my point. What is my point?
2/3 of
2/3 and -10. So what's y? -10 is equal to k times, what's x? 2/3. Tell me what to do. Divide by 2/3. What's a better way of saying it?
Multiply by the reciprocal.
Very good, multiply. But dividing by 2/3 is the same thing as multiplying by its reciprocal, right? 3/2. It's just a little nicer said that way. 3/2. So these cancel out and you're left with k is equal to.
-15.
Very good. 2 goes into 10 5 times. Divide by the bottom, multiply by the top. 5 times 3 is 15 and it's -15. Here's what they're gonna write in this blank right here. K equals -15.
No.
People, is that an equation that relates x and y?
It's
It doesn't even have an x and y. Okay, what's my equation?
Y equals -15x.
Perfect. And now I'm gonna use this equation, right? Because it says then find y when x is 12. Okay, so y is equal to -15 times 12. Y is equal to, well, 10 times 15 is 150. 2 times 15 is 30, and 150 and 30 is 180, so -180. Anybody got a question? Everybody okay? All right, is this hard? No. Okay, so we got 2 more problems to do. They're pretty quick. So here's the first one, example 2. We're gonna talk about hailstones. Hail, H-A-I-L. Alright? So, I'm gonna tell you that we have a hailstone, okay? Y'all know what makes hail? Yeah, like like you got some condensation up really high in the atmosphere, right? And it gets heavy, so it starts to fall, but the wind is blowing really bad, so it kind of blows it back up, and it's cold, so it kind of freezes. Then it picks up some more condensation, and the wind is blowing, it blows it back up, picks up some more condensation, freezes, and then it keeps doing that until it gets so heavy that it just does what? Falls to the ground, okay? Is it always cold when it hails? Mm-mm. Lots of times it'll hail like in the springtime, right before a storm or something like that, when it'll be cold up there and then that's creating the storm. Have y'all ever seen hail the size of softballs? Okay, so when I lived back in Arkansas, there was a girl from that town when it happened in the last period class. Monroe, Louisiana, okay? And they had a hailstorm and it was the size of softballs. The day after it happened, a friend and I, we went and drove to Monroe to see what it looked like. Oh my word. The windows were bashed out of houses. Cars looked like somebody had beat them with a baseball bat, and all the windows had big holes in them and stuff. There was not a leaf on a tree. Every leaf and stuff was laying on the ground. It was just a mess. I have never seen anything like it. It was crazy. So, it always makes me kind of nervous when it's hailing, like run inside. If it's the size of softballs, it's probably gonna do you some damage. So, this little piece of hail is 0.75 centimeters in diameter, and it took him 12 minutes to form. He was blowing around in that atmosphere for 12 minutes, gathering up condensation and freezing and stuff for 12 minutes. So here's what I wanna know. What if it blew around for 20 minutes? What would be his diameter? Okay?
I got a question.
Uh-huh.
Can't you set this up as a proportion?
Oh, you're the very first kid that said that. I didn't even tell the last class. Yes, direct variations are proportions. We don't teach them that way, and here's why. Because if I taught you to solve this as a proportion, could you have written this equation?
No.
See what I'm saying? You couldn't do it. You couldn't write that equation, all right? You wouldn't know what the constant of variation was, all right? So that's why we don't teach it that way, but y'all, that's all it is. It is a proportion, yes. Okay, so I'm not gonna teach it, I'm not gonna do it like a proportion, because we might want to write an equation that relates the diameter of a hailstone and the time that it stays in the air, okay? So, do you see a point?
Yes.
Which one is X and which one is Y?
Time.
Okay, so this is my X and this is my Y. This is my X and this is my Y. Now, if I asked you to write an equation, would you use X's and Y's? No. Did I give you X's and Y's? I gave you D's and T's. Do you understand? You give me X's and Y's and I'm like, what? There were no X's and Y's in this problem. Okay? All right. So, while my equation used to be Y is equal to KX, now it is what?
D equals to KT.
Very good. Diameter is equal to constant of variation times the time. And then we're just going to plug in the ones that we know. What is the diameter that we know? 0.75 goes with K times what's the time? 12. Is this a real life problem? Yes. Y'all, real life problems, people just use decimal. Okay? So divide by 12 and K is equal to. Somebody divide 0.75 by 12. What do you get?
0.0625.
All right, 0.0625. Good job. So there he is. Write me an equation. What if I said, write an equation that relates diameters and times of hailstones? What's your equation going to be? No Y's. What?
D equals 0.0625 T.
Yeah. D equals KT. D equals 0.0625 times T. Now we're going to use this equation and figure this guy out, right? Okay? What is my time? So my diameter is 0.0625 times 20. My diameter is 1.25 centimeters. Is that reasonable? If it stays up there longer than this guy, shouldn't he be bigger? Okay. Anybody got a question? All right, good job. One more problem, okay? This one, example 3, here's what we're going to talk about. Oh, yes.
That's a sharp.
It is.
I'm just gonna write sharp.
Oh. He got hungry.
Oh, so it's jaws.
He ate everything but the arm, okay?
Oh no.
All right, so here's our problem, okay? I went to the beach the other day and I caught a bunch of sharks. And I measured their tooth length in centimeters, okay? And I measured their body length in centimeters. Okay? The first shark I caught, are you ready? I'm fixing to call out your table. The first shark, his tooth was 1.8 centimeters and his body was 215. The second shark was 2.4 tooth and his body was 290. The next shark was 2.9 and his body was 350. The next shark's tooth was 3.6 centimeters and his body was 430. The next one was 4.7 centimeters and his body was 565. And the last shark, his tooth length was 5.8 centimeters and his body was 695 centimeters. So here's my question. Is there a direct variation between a shark's tooth length. And his body length. Do you think that there is? Seems reasonable, right? The bigger he gets, the bigger his teeth get. That seems like a reasonable thing to me. Okay, so, what are we gonna have to find out if it's a direct variation?
The constant.
Yeah, the constant of variation. So my constant of variation, so y'all are gonna have to get handy with your calculators, all right? So, who goes on top?
Tooth length.
Who goes on top?
The
Y
Y.
goes on top. Just like in slope, guys, okay? Just like in slope, Y goes on top, X goes on the bottom. So my constant of variation is 215 over 1.8. I'll do this for myself, okay? 215 over 1.8 is 119.44 repeating. Okay? Somebody else do the next one. 290 over 2.4. 120.83. Okay. Somebody do the next one. 350 over 2.9. Come on, y'all sit out there with the calculator. Y'all don't want to use it to help me, but y'all think I'm going to let you use it during a test. No. 6.9. Okay. What about this one? 430 over 3.6. Don't take so long. Let's go.
119.4 repeated.
Okay. What about 565.47? Okay. What about 695 over 5.8?
119.82 or 83.
Okay. All right. So there they are. Here are my constants of variation. Is this a direct variation?
No.
Is this real life?
Yes.
Yes.
Is real life perfect?
No.
Is real life pretty?
No.
If it's not perfect and it's not pretty, then all it has to be is close. Do you agree with that?
I don't care, can you just, also can you find it, like, if you subtract 290 from 215, and then keep, like, subtracting
No.
the others?
Okay, so I'm gonna ask my question again. Remember, life's not perfect, okay? Like when you have a baby, is your baby gonna grow exactly and stay on that the little line that he's supposed to stay on at the doctor's office? Like when he's 3 months old, he's supposed to be right here. Is he gonna be right there?
No.
No, he's not gonna be right there. My husband's 6'5", he probably wasn't right there, okay? He was probably way up here, and then I'm so short, I was probably way down here. And then we had some average kids, all right? So, is this a direct variation?
No.
Yes.
Yes, people, look at those numbers. Are they so close to each other? Yes, they're so close. If I said, hey, people, what do you think K is? Shout it out to me right now. What do you say? What? Just look at it and go, I think it's this. Thank you very much. That's what I think it is called. 120. 120. I got that wrong, didn't I? Sorry. All right, 120. Constant of variation. If I wanted to be exactly and precise, what would I do with all these numbers? Add them all up and do what? Divide. I would average them, right? Add them all up and divide by however many they are. Okay? So here's what I want to know. Can I use this to predict? Let's say I went walking on the beach and I found a tooth that was 6.7 centimeters. Could I predict how big that shark was?
Sure.
I mean, you could, you probably would get it wrong.
Why would I get it wrong?
The cavity is
variance.
How close are these numbers, people?
Very close.
Y'all, those numbers are within one of each other. Do you, I mean, that's so close. They're in within one of each other. Okay? I mean, that's very, very close. How would I find out what his body length is? What would I do?
You would plug that into X, right?
It would be plugged into X, so what would I do with it?
You would multiply that with 120.
That's exactly what I would do with it. It would be 120 times 6.7, and so he would be 804 centimeters long. A mega shark, right?
That's a big shark.
Mega shark. And then I'd be hollering, I'd like, what? I got a big tooth.
That's a
All right?
massive-
Now, does that mean that every shark fits within this little band? No, people, they don't. Is there going to be a shark out there that has a gigantic body and little bitty tiny teeth? Yes. Are there lots of them? No. You know why? Because they don't get the girls. All right? Like in nature, who's always doing all the chasing? Who's always trying to catch somebody? Who are the pretty ones? The guys. Think about birds and stuff. Who are the pretty birds? The guys are the pretty birds. Okay? Why? Because they're trying to get the girl. All right? So when you get a weird shark out there, okay, that he either, has teeny tiny little teeth and a gigantic body, the girls are like, oh no, please, please. All right? Okay, so let me give you your worksheet. When's it due?
Friday.
Next Friday. Very good. When your test will be.